Hi everyone, welcome back to the CC425. We already scanned all of your meeting exam, and the feedback will be posted on B12 tonight. And so I will quickly discuss the question for the problem 6. So basically, it's only the design questions. Okay. So idea is okay. So if you, for example, if we try to protect the FBI, okay, employees, okay, prevent them from suffering from the like a social engineering attacks, how can we deal with this? How can we develop a system for that? So they assume we are able to monitor all their communication channels, so we can extract the features. Okay, by monitoring all the communication channel, we can obtain the transcript, right? So we can collect some features to highlight the potential attacks. So which means that we can use a feature-based, okay, approach. If we identify some potential social engineering attacks, then we can redirect the low layer request messages, okay, from external users to the honeypot we deployed, so that we can collect more information about the social engineers, so we can further arrest them. So basically, this the concept for this one of the solutions to deal with this social engineering attacks. So you can develop if your answers are okay, are different from that is fine. It depends on if you can provide the rationale to justify your solution can work. Okay. So these are for the design questions. Okay. So in the final exam, because I say it could be the open book. So basically you will see the more design questions. So because it's open book, so I don't. Yeah, you should not just copy paste. Okay, the answer from the slide. So you will see the more design questions. So you will be given some scenarios. Okay, leverage all the information you learn from this course and address that. Okay. So yeah, I will also discuss the mechanism with the TA later. So yeah, if I find more questions, more problems, you lose the point a lot. So I will discuss then this Wednesday. So another thing is okay, the course project has been posted on D2L. Okay. So the deadline will be the 1 month later, so be April 11th. Okay. So you see a lot of highlight words there. Okay. So basically, this course project is we try to launch the website defacement attack, which means when you access in the website and you will receive the malicious content rather than the original content. Okay. So this project can be only conducted in a controlled environment. Okay. So which means that you cannot do this attack on the campus network. You need to do this project on your own Wi-Fi networks, and you can only attack your own devices. Otherwise, you will receive a zero, and you may face some legal issue. Okay. So yeah, so idea is okay. Yeah, in this project, you are required to deploy your own Wi-Fi network. Okay, here I provide you some uh, website. Okay, let me see. Let me see. Oh, probably I didn't add the, okay. So idea is, okay, you can convert your laptop into a Wi-Fi access point, okay? Most laptops support this functionality. Yeah, I forgot to put the YouTube tutorial link here. But if you Google how can I convert my laptop into the Wi-Fi hotspot, I think it's not difficult for you to find the tutorials. I will update the this project description later to provide you with this link. So if your laptop, you cannot cover your laptop into a Wi-Fi hotspot, that's fine. We will deploy the Wi-Fi as a point nearby the engineering building. Okay, 2153. So you will see the Wi-Fi access point named the CSE 425 1. and then here is a password. Okay, so if you cannot deploy your own Wi-Fi network, then you can use our Wi-Fi access network. Okay, then you can connect your device to the Wi-Fi access network. Okay, so basically, in this project, it comes with two tags. Okay, the first one you will receive a 25% of project score, and then test two you'll receive a 75. So first one is okay. You assume you can connect two computers with the Wi-Fi, your Wi-Fi network over our deployed Wi-Fi network, and tell me how can you discover the victim IP address from adversary IP address from adversary device. First of all, you connect two computers with a Wi-Fi, your Wi-Fi network or our Wi-Fi networks. One computer will be adversary, the other will be the victim. And tell me how can you discover the IP address assigned to the victim device. Okay, so you can use some tools, okay, to discover the victim device. Okay, both devices are provided by you. Okay, you connect two devices with a Wi-Fi network. One is an adversary, the other is a victim. And from adversary device, you need to tell me how can you discover the IP address assigned to a victim device. There are some tools can help you to complete text easily. Okay, I mentioned that in a class. I think it's a. I forgot the name. Okay, it's more like a film. Okay. So basically, this tool can help you to discover all the devices within the network. Okay. For example, if we are connecting to the MSU net guest. Okay, if we try to discover how many devices connected to this campus Wi-Fi network, we can use this tool. Okay, so we can discover all IP addresses used by the different devices. Yeah, I already showed some result in the slides. Yeah, couple weeks ago. Okay. So let me see. So first test should be easy. Okay, you just use this tool, you can find all IP address, all the devices connected to this Wi-Fi network and discover their IP addresses. And the second task is more challenge in this course project, but it's not difficult. Okay, so idea is that you require to access the www.csc.ms.edu from the victim device. Okay, so from the victim device, you go to access it. Okay, so now let's take a look. HTTP. Okay, I didn't use HTTPS, means I don't want to enable the TLS. Okay. Now I click enter. So you will see your page, your request has been redirected to another link, right? And then this one come with the HTTPS. Okay. Let me tell you what happened when you click the enter. Okay. We send HTTP request to the CSC website server. For the sake of security, the website should not respond anything to us. They should ignore our request. However, they use the HTTP protocol without TLS, send a message to us, say, okay, this link has been permanently changed to another link. Okay, this message is not encrypted. It's a plain text, which means that everyone in the middle, they can manipulate this plain text response. So I can tell you, okay, please redirect your. I can tell the victim's browser, please add another link provided by adversary in the middle, right? So in the normal case, in the best case, our CSC website server should not respond to any request if they are not HTTPS request. Okay, but anyway, this is common issues. Okay, because they try to provide a user with a better compatibility. Okay, so anyway, now you can know if we don't support, if our server does not support HTTPS protocol, the man in the middle can launch attack because they are able to fabricate the response from the server. Okay. Okay, now you're required to do one thing. When the victim device try to access this website, then at the adversary device as a man in the middle, you need to provide the victim device with another link so that they will see something different. In this project, if your victim device, if you can see this page on the victim device, means you fail in the test too. Okay, if you see anything different from this page, then you pass. You earn the 75%. So it's not difficult to earn 100% of in this course project. Okay. And you can use a lots of basically we have a lots of attacks can achieve this goal. The easiest way to achieve this attack is you can leverage in the DNS spoofing attack provided by EtherCap. EtherCap is more like attack toolkit. It provides you with a lot of pre-developed tool, and you can launch different attacks. DNS spoofing attack is one of them. DNS spoofing attack is that okay. Okay, to launch this attack, you need to guarantee the victim. You can clear the DNS cache on your victim device first. What is a DNS cache? For example, if this is the first time for your victim device to access this domain name, www.csc.ms.edu, he will send a DNS query to DNS server. But if this is not first time, he already did such query before, he will directly use a DNS cache. So DNS spoofing attack will not work. Okay. So guarantee you or before launching this attack, you have to make sure all the DNS query cache has been cleared. Otherwise, this attack may not work. Okay. Here I provide you the tutorial for EtherCap and the tutorial for how to launch the DNS spoofing attack using the EtherCap. DNS spoofing is that we will develop a fake DNS server. When the victim device send any DNS query, their request will be redirected to the DNS server. Then on your fake DNS server, you can provide them with incorrect mapping. For example, okay, ideally you need to configure the DNS spoofing configuration files provided by EtherCap. The configuration allows you to monitor specific domain name, for example, like www.csc.ms.edu. And they also provide you a mapping table. You can map this domain name to a particular IP address. When any guys try to query the IP address associated with this domain name, then your fake DNS server will provide them with a predefined fake IP address for that. Okay, that's how the DNS spoofing work on the EtherCap. Okay, you can watch this YouTube. Basically, you just need to watch this YouTube and do it step by step, and you can get it done. Okay. So, any questions? Yeah. Another thing is why I encourage you to convert your laptop, okay, into the Wi-Fi hotspot. The reason is okay. In the recent years, okay, the Wi-Fi router manufacturers, they deployed lots of security mechanisms or defenses on their Wi-Fi router to help them higher layer user defend against a variety of attacks. Which means some commercial Wi-Fi routers, if you purchase expensive one, for example, like higher than $100, they may come with some advanced security defenses. They can defend against a DNS spoofing attack. Actually, the DNS spoofing attack, you may wonder why when the beacon device send a DNS query, why this query is not sent to authentic DNS server, why this message will be sent to the fake DNS server deployed by AetherCap. The reason is before the AetherCap launched a DNS spoofing attack, it already launched the ARP spoofing attack. They can fake a device, they can fake a server as a malicious DNS server. When the user tries to send any packet to the real DNS server, they will be forwarded to the malicious server deployed by AetherCap. So actually, DNS spoofing attack integrate another attack, which is ARP spoofing attack. Yeah, if you are interested in that, you can just Google it and find more information. Okay, this technique is pretty common. Let's allow the adversary can hijack other people's packet and intercept them. Some Wi-Fi routers, okay, deploy the security mechanisms against the ARP spoofing attacks. If you use such Wi-Fi router in this project, and your attack may not succeed. Okay. Yeah, just let you know. Okay, some students may experience such questions. So that's why I encourage you guys to convert your laptop into the Wi-Fi hotspot, because usually for such in such mechanism, they will not help you deploy the additional security mechanisms. They only deploy the basic functions required for the Wi-Fi routers. Yeah, you may wonder what is the difference between a Wi-Fi access point and a Wi-Fi router. Yeah, when I introduce a network security, wireless network security, I will introduce more details. So basic idea, okay, in practice, we configure Wi-Fi routers, okay, to be sent as a Wi-Fi access point. The reason is that on the market, you cannot purchase a Wi-Fi access point anymore. Wi-Fi access point means that they only implement the physical layer and the MAC layer required by Wi-Fi standard. Wi-Fi router means that you will not only implement a physical layer, MAC layer, but also implement the link layer and the network layer. Network layer is, for example, you can share your IP address with multiple devices. You can convert your Wi-Fi router into the IPsec, okay, which means you can configure Wi-Fi router provide us more functionalities than Wi-Fi access point. But on the market, we cannot purchase the Wi-Fi access point anymore. All the Wi-Fi router, all the Wi-Fi access point come with additional link layer and the network layer functionalities. By the way, another thing, okay, we have many students. Okay, you don't need to work on this project by your own. You can team up with another 2 students, okay, which maximum number of students each grade is 3, okay. And yeah, special requirement is okay. Yeah, you can only launch an attack against yourself and your own device. You can launch attack against any other devices, okay. And this project can be only done within your own private network over the Wi-Fi router deployed by us. Okay, they will be deployed nearby the EV2153. Okay. So for the project submission, okay, yeah, you have a month to do this project. So usually we will require the student to demo, okay, what they did, okay. But since we have a lot of students this time, so you don't need to schedule appointments with the TA, but you record your demonstration, okay. You can use like a Zoom, okay. For example, just exactly what I did here, okay. So all the team members, you need to show up virtually or physically in the video. The reason is some students may just reuse other people's video recording and submit again. So I want you guys to show up in the video recording. Make sure you are the guy perform the operations. Okay. Let me see. Okay. So in addition to the demo video, okay, one-page report, okay, just one-page report, okay, use later side to specify your team members, okay, and briefly introduce how you complete the test 1 and the test 2, okay. Yeah, if you write some code over the script, okay, you can also upload it if available, okay. But basically, yeah, doing this project is not difficult. You don't need to write any program. You just need to know how to use this tool at a cap. Okay, you have to know how to use a fin, FING, and add a cap so that you can get this project done. Okay, it's not difficult. Okay. So if you find okay, you are in if you are using the Wi-Fi network, which is vulnerable to the up-spoofing attack, you should enable the VPN. Okay, by using the VPN, they can help to defend against the variety of cyber attacks. Okay, if you think you are using untrusted networks. Yeah. So any questions? Yeah. Usually, when you start to work on this project, you will have more questions. Okay, so my suggestion is do it early. Okay, so if any question, you can get back to me or TA. Yeah, before the meeting exam, I introduced the firewall. Okay, so let me quickly go through them. Okay, so firewall is we deploy a firewall between the internal network and the external network. The internal network is like enterprise network, the network we try to protect. The external network means untrusted network. Then we will receive a request from external network. So we deploy the firewall between the internal and the external networks. Okay. So firewall can help us to remove the suspicious packets. They can help us to block all the suspicious packets. Okay. So we have the 4 types of firewall. One is a packet filter firewall, which means we can either accept or reject a packet, incoming packet, depends on information from this packet only. So which means that we cannot leverage the states or information we obtain from the other packet. We need to make decision based on information of this packet only. It's the simplest one. So it's a complete, okay, we can deploy that on like a router, okay. So this is a complete packet filter firewall, and we also have a stateful inspection firewall, which means we will not only leverage information obtained from this single packet to determine which should pass or deny this packet. We can leverage information we collected from the other packets. Okay, this is considered stateful inspection firewall. And the third is application proxy firewall. Basic idea is okay. We will deploy the application proxy, for example, like a HTTP proxy or FTP proxy or SIP proxy. We will not allow the user to directly access our application servers. Instead, we will allow them to communicate with our application proxy first. Application proxy firewall will do following things. They will remove the all unsupported message headers. Okay, they will clear all unsupported information from the user's request, from the external user's request. Then they will only transmit a clean supported HTTP application request to our HTTP server. So they can help us to better protect our application server. And the circuit level proxy firewall is different. They will not pay attention, compared to the application proxy firewall, pay attention to application layer. Circuit level proxy firewall pay attention to the transport layer. They only pay attention to the TCP connection or UDP session, which means, okay, you cannot establish the connection, that you cannot establish the TCP connection with our application server directly. Your TCP connection will be split into the two connections. One is between the external user and our circuit level firewall. The other is for our circuit level firewall with the application server in our internal network. So then we can use this circuit level proxy firewall to determine which user is permitted to establish a TCP connection with our application server. Yeah. Okay. Then here, there are several types of firewall. One is a Bayesian host. A Bayesian host means, okay, we develop a machine, install the secure operating system, and this Bayesian firewall can help us to monitor all incoming and outgoing packets. Okay. So what we say is a Bayesian because the operating system he installed is quite different from the servers or the laptop. The OS used by that. Okay. We will remove the all unnecessary services. Yeah. Whereas the conventional, for example, if you download the default Ubuntu operating system, it comes with lots of service application you may not use. Then we have the host-based firewall. The host-based firewall is for the server. Okay. Then we have the personal firewall is for the individual user. Okay. So, okay, here is the example how we deploy the firewall. Okay. So we can deploy the firewall. Okay, we can have an external firewall. Give me a second. We have an external firewall. We have an internal firewall. Okay. The network between the external firewall and the internal firewall is called the DMZ. Okay, demilitarized zone. Okay, so we will put some the servers provide users with interfaces functions there. They don't store any critical information. For example, like a user account, user password, or a user credit card. They are allowed to communicating with our data server, okay, in the internal protected network, okay. Then once they obtain the data, they present the data to the user. So that's why I said they are interfacing servers. They don't store any sensitive data. So the main benefit why we separate the interface and the data in the network because we can deploy another firewall, internal firewall to monitor all the information transmitted from our internal protected network to see if there are any information leaked to the external user. And we have several topologies for the deploying of firewalls. Okay. So basically, you need to know the why each firewall topology is. Okay. What they are. Okay. So for example, here is here is a host resident firewall, which means we deploy the firewall on personal computer. Okay. Then we have the screaming router. which means we deploy the packet filter firewall on our router. They can determine if a packet can pass or discard based on information collected from this packet. Then we can have a single Bayesian inline. Single Bayesian inline means we purchase the Bayesian firewall. The Bayesian firewall is you can consider it's a powerful machine. Okay, deploy the firewall functionality, install a secure operating system. Okay, single Bayesian inline. Okay, then we have a single Bayesian T. Single Bayesian T means okay, we added a DMZ zone attached to the Bayesian firewall here. Okay, it's a single Bayesian T. And we have a double Bayesian inline, which means we deploy the two Bayesian firewalls. Okay, then the DMZ zone will be deployed between the external firewall and the internal firewall. Okay, and another is the double Bayesian T. Okay, and you asked why they introduced previously. You may be asked which one is most secure. If we compare the double Bayesian inline and the double Bayesian T. Okay. Now you may see this question in the exam. Okay, but I will not. I didn't write the answer. Okay, in the slides. Okay, so basically this one will be the most secure. Okay, consider one thing. Okay, we deploy the interface server in a DMZ zone. If we try to present something to the external user, eventually we need to obtain the data from the internal network, right? So if here is the machine, okay, we receive a request from the external network. Then we send a request to fetch the data from the internal network. Okay, our request issued from DMZ zone need to pass internal firewall. Okay. But if we deploy a double Bayesian T, we attach the DMZ to external firewall. When the DMZ zone try to fetch the data from the internal firewall, his request will be sent to the external firewall first, right? And the external firewall will forward it to the internal firewall and finally arrive at the internal network. So which means the request from the server in the DMZ zone need to pass both external firewall and the internal firewall if we are using a double Bayesian T. However, if we are using a double Bayesian inline, the request from the server in the DMZ zone just need to pass internal firewall. They can reach the internal network. Okay, so the next is okay, distributed firewall configuration. Okay, so basically, you can see we deploy almost firewall everywhere. Okay, we have the Bayesian firewall as the external firewall and the internal firewall. Okay, they are Bayesian firewall. And on the server, we will deploy the host firewall. On the workstation, we will deploy its application. Yeah, on the the workstation, we will deploy the personal firewall. So basically, we leverage the Bayesian firewall and the host firewall and the personal firewall. Okay. Okay, so the next is intrusion prevention system. Okay, so basically this IPS is similar to the IDS. IDS is a intrusion detection system. The only difference is okay, the IPS can block or prevent detected malicious activities. What do you mean by block? For the detection means once we detect malicious activity, then we can send alert to the managers. But we cannot choose to discard this packet or send a reject back to the sender. Okay, whereas IPS is allowed to do so. Okay. So yeah, So for the detection model, basically IPS still uses the same approach. What we use in the IDS, we support anomaly detection, which means we find anything different from the benign users, they are complete anomaly. And then we can use a heuristic or signature-based detection to identify the malicious activity. Basically, we base on the features of the known attacks. Okay. Yeah, I can skip that because this part is the same as IDS. Okay. So here is okay. Disputed IDS. So basically okay. This slide will leverage the most information I introduced previously. Here is a firewall. Okay, we have a passive sensor, which means NDIS. We also have a honeypot. Okay, and we have a correlation server. Okay, and we have a application server execute the malware. So basic idea is okay. How do we know we are suffering from the intrusion attacks? So we can collect those information from the different sources, including the firewall, including the passive sensor, including the honeypot we deployed, including the application server we deployed. And then we will send the report to a correlation server. And the correlation server will go to analyze our report and identify the potential vulnerability and then provide a patch. And then finally, the patch will be deployed on our application server. So basically, it's more like provide you with a life cycle. How can we detect the intrusion and the malicious, like malware, okay? And then once we discover, and how can we deploy the solutions? So the Snowden has another version is called a Snowden inline. He can support the drop, reject, and the silent drop. These three operations is considered the operation required by the IPS. So we can discard the packet and we can even send a reject to the sender. We can terminate their TCP connection and we can terminate their application sessions. So that's why the IPS can prevent potential intrusion rather than just detect them. So here is the machine, special machine named the UTM, Unified Threat Management Appliance. Okay. So basic idea is okay. There is a raw incoming traffic and output will be clean controlled traffic. Okay. So basically, yeah, it's more like this machine is more like appliance. Okay, you can purchase this machine and deploy it in your network. Okay. So first of all, it comes with a lot of module, for example, routing module, VPN module, and firewall. It can come with the antivirus engine, the IDS engine, IPS engine. Okay. Then they can deploy the different scan engine, for example, like heuristic, anomaly detection, and activity inspection engine. So they will also perform the anti-span, web filter, and the bandwidth shaping modules. So basically, it's more like okay, we deploy the server. They will monitor all the incoming traffic, but they will not only monitor them only. He will also modify the incoming traffic, remove all the unsupported headers data from the incoming traffic, and then make sure the output will be clean and controlled traffic. So this machine is, for example, here is the Sidewinder G2 security appliance. Okay, he can defend against a lot of attacks. Okay, now here just give you some idea. Okay, in the TCP layer, he can support the invalid port number use, invalid sequence number, SIM flooding attacks. Okay, and in the TCP, he can support invert TCP, a UDP packet or random UDP data to bypass the rules. So basically, you can see they support to defend against a lot of different attacks. Okay, but the main drawback of this UDM appliance is if we just rely on this single appliance to protect our system, once it's been compromised, and our system will suffer from the attacks. So basic idea is, okay, in the practice, we may purchase one single UTM machine to protect our system, but we also need to deploy like low cost personal and the server firewalls on our machines. So once this the UDM appliance is compromised, we still can protect our systems. So any questions? No more question. There'll be all for this lecture. Okay, now let's take a look at the buffer overflow. Okay. Buffer overflow is a very interesting attack. Okay. Usually, when we try to launch attack by using the malware, we need to deploy the malware on the victim device. But buffer overflow allow you to upload your malware on victim device without installing them in advance. So it's quite interesting. Okay, they can change the the return address of the program of the function invoked, so they can jump to any program you like it to execute. For example, okay, if here is a program used by the super user, when this program is executed, he will obtain the super user's permission. And after this program is complete, he should go back to the super user control. But if you are able to modify the return address of this program, then you can redirect this control to your malicious code. Then you can obtain the super user's privilege. Then you can do everything you want. So this is the beauty of the buffer overflow. Okay. So buffer overflow is a very common attack. Okay, was used by the Morris Brown in the 1989, and the prevention techniques are known, but they still consider the major concern because due to some resource issues, okay, their techniques cannot be deployed. Some prevention technique require specialized hardware. Without a specialized hardware, we cannot deal with it. We cannot prevent a buffer overflow attack completely. So buffer overflow, also known as a buffer overrun. So it, by the definition, is okay, a condition at the interface under which more input can be placed into a buffer or data holding the area than the capacity allocated. For example, if the buffer size is 8 bytes, but you try to write the 9 bytes into this buffer, it's considered buffer overflow. Okay. Yeah, you may consider, okay, if I just write some data more than the capacity, it's not a big deal. But actually, we can carefully design what the data we override into the buffer, then we can launch lots of interesting attacks. Okay, so let me see. Yeah, so it's a considered programming error when a process attempts to store data beyond the limits of the fixed buffer. Okay, so the buffer here we talk about can be the stack, heap, or the session data of the process. Yeah, I will introduce what the stack, heap, and the session data are later. Okay. So the consequence may be the corruption of the programmer data. Okay. For example, if you write the data more than the buffer capacity, you may corrupt other people's data. So you will lead to the corruption of program data. But if you carefully prepare the data, then you may launch the unexpected transfer of control. Yeah, I will talk about what is the transfer control later. There can be the memory access violation. Okay, they may force your computers to terminate. Okay. Then you are able to execute the code chosen by attacker. Okay, let's take a look at the standard buffer overflow attack. Okay, yeah, here is a function. Okay, it's a program written in the C. Okay, so we have the three local variable. One is an integer value. Okay, it could be true or false, and we have a two string arrays. Each one come with 8 characters. Okay, we have a string 1, string 2. Okay, now in this function. In this main function, we call the next tag this function. Next tag this function is a set string 1 to the start. Okay, so you can configure with just call this function and set the start to the string 1. Okay, the next function is get. Get is a way to obtain the input data from the terminal. User need to provide the input data. So the data will be set to the string 2. Okay, we call this get function. And the next, we will compare string 1 and the string 2. Okay, it's a str. N means okay, how many characters you want to compare. You can say I want to compare the first 8 characters. Okay, string 1 and the string 2. Okay, if the first 8 characters of string 1 and the string 2 are equal, this function will return 0. Okay. So if this is 0, value will be set to 1, which means they are these two functions, these two strings are equal. Okay. Then we compile this program, okay, into the buffer 1. Okay. The name of this program is a buffer 1. Then we execute the buffer 1. Okay. So first of all, the output, okay, the first we will receive, we'll execute this function. Okay. We provide the start to the string 2. Okay. Then the program will compare string 1 and string 2. Okay. So because string 1 is a star, string 2 also star. So he will output string 1 is a star, string 2 is a star, and they are equal. Okay. And we call this function again, but this time we didn't provide you with a start. Instead, we provide you with something longer. Okay. We provide it with a evil input value. There's something interesting will happen. Okay. The string 1, his value is a t value, and the string 2 is a evil input value. They are not equal. Okay. But if we put the bad input okay, as input data for the string 2, what thing will happen? Okay. So string 1 is a bad input, string 2 is a bad input, and the comparison result is a 1, which means they are string 1 and the string 2 are equal. So you may wonder how is it possible we are able to change the string 2 to something different from the sorry, how is it possible for us to change the string 1 to something different from string 1, different from the start? Is here we call the next tag. We already set the start to the string 1, right? String 1 is not input. The input should be provided for the string 2. Okay, no matter what the data we provided, we should not overwrite string 1, right? But based on this 2 example, we can see string 1's value can be modified. Okay, he's no longer start anymore. Instead, he's changed to something different. Okay, let's take a look at the stack of this program. Okay, So actually, when we execute this function, okay, we will load this function into our memory, and based on all the local parameters and based on which where this function is invoked, we need to create a stack for this function. Okay, basically it's for this process. We need to create a stack for this process. Now here we can see we have a valid. There's a local parameter. It's a valid here. It's a local parameter. 4 bytes. Okay. Then we have the string one. String one is come with 4 bytes, 8 bytes. Okay. So he used the 2 blocks here. Okay. String two also use 8 bytes. So we'll use a 2 block here. Each block is a 4 bytes of a memory space. Okay. So now let's take a look. Okay. When we call the gets, we will read the data from the terminal and write them to the string 2, right? So the string 2, it provide us, the user provide, okay, bad input for the string 2 is the 16 byte, 16 characters. Okay. So we will override the bad input for the string 2. We also overwrite the string 1 because string 1 is adjacent to the string 2. Okay. If we provide a longer data, if we provide data longer than the string 2 capacity, it will go to overwrite the string 1 because string 1 is adjacent to the string 2. Okay. Now we can see that something interesting here is a return address. It's a base, old base pointer. It also comes with okay input parameter and the number of the input parameters. Okay, so which means that if we can carefully manipulate the input data, then we can override the return address. Then we can measure, okay, we can change the control of this process. Why we can do it? After this process is finished, he will refer to the return address and transfer his control to a return address. Okay, if we can change the return address to a memory address storing our malicious code, then we can transfer the control of this process to our malicious code. Then we can do anything we want. Okay. Any questions? So yeah, so basically buffer overflow attacks, okay. To avoid the buffer overflow attack, attacker needs to identify the buffer overflow vulnerability in some program. They can be triggered use external source data under the attack control. Because most actually nowadays, okay, in both the commercial or the free software, they use lots of open source libraries or software. So by analyzing those open source program, then we are able to identify the buffer overflow attack vulnerability. Then we can use some tools help us to efficiently and quickly identify those vulnerabilities. For example, like a fuzzy. Okay, this tool will help us to identify the programs vulnerable to buffer overflow attacks. So you may wonder why we have such issues. Okay, the idea basically is caused by the buffer overflow attacks will not happen in some high-level programming languages such as the Java, okay, or Python. those programming language will not allow you to directly access the memory. But some programming languages such as the C or C++, they allow the user to directly access the memory. So for such buffer overflow attacks can be only applied to such low level. We cannot see we cannot consider C or C++ as a low level programming language. Okay, such programming language allow us to manipulate the memory directly. Okay, buffer overflow attack will be only applied to such programming language. Yeah. So you may wonder why we not just replace the C with Java or Python. The idea is to use to perform the Java or Python programming language. The programs we need to install the interpreter. On some resource constrained devices, they may not have enough resource for these interpreters. But the C is different. C, we can compile C program into the machine code directly, and they can allow those they can allow this resource constrained devices to perform the programs. So that's why the C is still popular on the mobile devices nowadays. Okay. Yeah, here I like to introduce why we can launch how we can change the return address by attacking the stack. Now, assume we have two functions. One is a P, the other is a Q. Now, in this example, is a P calls Q. Here is a P. P basically will try to here's an integer I, and he will call I will be the input parameter. They'll be sent to the Q function. Q is another function. So let's take a look at how the stack look like in these two functions. So here is a Q. When a Q is invoked, he will basically we will prepare the stack for the Q function. In the Q function, the two information will be stored. One is the return address in the P. The other is the old friend pointer. The old friend pointer will be pointed to here. Will be pointed to the old friend pointer of caller. Then we will declare the two local parameters required by the Q. The local parameter will occupy the stack memory. When the Q is finished, he will return to the P. That may be in the middle of the P. So when the Q finished, the control will be returned to here. The J plus equal to the Q of I. So once Q is finished, the control will be returned to here. So if we try to transfer the control after the Q is finished, we can transfer control to another malicious program. Then we just need to modify the return address here. Then once Q is complete, and we can transfer the control to any memory address storing the executable code. Now, actually, in addition to the stack memory, we have the three types of memory when we execute the functions. For example, we have the stack. Stack is used to stack memory is used to store the return address, all frame point, and all the local parameters. And the heap memory. Heap memory is for those memory will be dynamically allocated to user and deallocated and will be released to the operating system. We have a heap. For example, like the M allocate. You can require 1024 bytes memory. And this dynamic allocated memory will occupy the heap memory. Then we have another type of memory for the global data. If we have the 5 functions and they share the one global data, there's a global variable. The global variable will occupy the global data memory. So we have 3 types of memory: stack, heap, and the global data. Stack is for when this function is invoked, we will store his return address, all frame pointer, and the local permit for this function. For heap memory, if we need a dynamic allocated memory, we will use a heap memory. If our program declares some global variable, they will occupy the global data. So in this example, we can see, okay, from the input, if we have an input array, his array is 16 bytes. From the input, at the beginning of input array to the frame pointer, they will be the 24 bytes. So if we try to overwrite all base pointer, we need to prepare the 24 plus 4 bytes of data. If we try to overwrite the return address, we need to prepare 24 plus 8 bytes of data. Then we can overwrite this one. Yeah, in operating system, we have a little Indian and a big Indian format. So basically, just okay, how we store the data in the memory. Okay, one is okay, large significant bit will be put at the rightmost. Yeah, basically, we are using the little Indian or big. We can use a little Indian or big Indian in operating system. So before we launch a attack, we need to know the which format is used by operating system. Or they are using the little Indian or big Indian. So here example, okay, show you how we can launch attack. Yeah, you may wonder how is it possible for we launch the buffer overflow attack to change the return address, because not all the binary data can be provided over the terminal window, right? So basically, there is a tool, is a program Perl. They allow us to provide the decimal input value for our program if we call a specific function. Okay, so it's similar to the what we saw in a buffer 1 is a program. Okay, we can use this Perl and the print pack function. Then we can pack the data, binary data in the string format and pass them to the buffer 2. Okay. So now here you just need to know, okay, in this hello function, we compile this hello function into the buffer 2. Okay. In this function, he has an input array with the 16 bytes. Okay. Its capacity is 16 bytes. And we can pass such thing to the input. Then we'll see what thing will happen. So now we know, okay, the input array, he only supports 16 bytes. If we provide the data more than 16 bytes, we can overwrite the other things, right? So the 16 byte of data is from here to here. This 16 bytes. Oh, not. Let me see. Oh, sorry. Yeah, we provided the 24 bytes of data here. The reason is we need to overwrite the base, all base point and the return address. So then we can overwrite the base, all base pointer with this one, and the return address with this one. Okay. If we assume that return address is a beginning of this hello function, so then we will see after we provide input data for this hello function, we find that the hello function is invoked again. When this function is finished, the function should not be restart again, but we change his return address to the beginning of this function. So this function is invoked again. And his input will be, we provide here, n, and the new line. Okay. This is the input data for the hello function when he is revoked second time. So here, just use the example to demonstrate we are able to perform this function, invoke this function twice. And we can also provide a different input parameters for these two functions. So if we are able to upload our malicious code to the victim system, and we know where our malicious code is stored, we can obtain the IP address. Then we can change the return address to the place store our malicious software. So then we can do everything we want. So there are lots of unsafe, okay, the C library. Yeah, for example, like the gas, sprintf, strcat, str copy, string copy. Okay, they didn't specify they will not check the capacity of input parameter, so they may override the other people's memory. So they are considered unsafe the C library. So now here is I would like to introduce a common attack that will be used by the adversary. It's a share code. Okay, so share code is more like I think. Let me see. Yeah. So if you see the command prompt, basically is a shell. Okay, you can do a lot of commands here. Okay. So the idea is why the adversary want to use a shell code. Basically, is they try to pre-compile the shell code program and upload this program to the victim device, so they can launch a buffer over attack and transfer the control of the program to their shell code. So here is if we want to write the shell code, okay, this is a common function. It's a main function of the malicious program. Okay, basically based on this function, we are able to invoke a shell program. So we can run lots of commands, such as dir, such as copy, delete, okay, or FTP. You can run all the commands supported by the shell code. Okay. Now the thing is that we write this program, then we compile it into the assembly code. Then finally we can convert assembly code to the machine code. Okay. Now you can see we added two NOP. NOP means no operation, and they will be compiled into the 90. Okay, 90 means no operation. 90 is very important to increase the successful rate of the launching the buffer overflow attack. I will introduce why. Okay, the most challenging part is if we try to launch the buffer, if we try to upload the pre-compile the share code machine code to the victim system, and then we want to transfer the control of the program to our machine code, we need to know where our machine code is loaded, right? But as an adversary, you have no idea about where your machine code will be loaded, right? You need to guess. How can we increase the successful rate? Then we can guess where our machine code is loaded. The no operation, which is 90 here, is important technique will be used by an adversary. Yeah, here example. Okay, we can pass the machine code of a share code as input to a program, right? We have no idea about where our data will be loaded. So if our guess is incorrect, the control will not be given to our share code, right? So, but we are able to add lots of 90, which is no operation. For example, we can add the 90, we can add the 950 no operation to our malicious machine code. Okay. So then if our guess is not at the beginning of our machine code of share code, but in something in the middle, it doesn't matter. It eventually will lead to our share code. Okay. So by adding a lot of no operation in our share code, we can increase the possibility of getting the correct the memory address storing our machine code. So any question for that? Yeah, no matter what you guess is, okay, here, that eventually will go to your machine code. Okay. But if you don't add the no operation, you have to provide it with the accurate the memory address store your machine code, like 1000 here. Otherwise, your share code will not be executed. Yeah, just something. Just these two slides just for how we generate the assembly code and the machine code from the share code. Okay, we can skip that. So here example. Okay, you may see this question in the exam. Okay, I will provide you with the stack frame. Okay, and you require to modify the return address. Okay, I will ask you to prepare amount of data so that you can change your return address to the specified one. Okay, so basically idea is that, okay, I will give you the data number, the byte numbers we require to overwrite the return address. For example, it should be the 88 byte here. Then this one is the old base pointer. Okay, 88 plus 4 will be the old base pointer. 88 plus 8 will be the return address. Okay. So which means if I ask you to override return address to like 1, 2, 3, 4, okay, then you need to prepare the 88 plus 4 byte of junk data, which means I don't care what the data you put there, it doesn't matter. Okay, the only last 4 bytes is important. You just need to put the last 4 bytes to 1, 2, 3, 4. Then you can change the return address to 1, 2, 3, 4. Okay. So any questions? Yeah, you just need to prepare the correct size of junk data, and finally you can override return address. Then how do we know what the return address we should provide? How can we increase the possibility of guessing the correct memory address storing our malicious code? We can use the we can use the no operation code. We can put lots of no operation code to our share code, so that no matter where the share code is loaded, we have a high chance to find a useful memory address. Okay. Okay, and next I will discuss some defenses. Okay, how can we defend against the buffer overflow? So we have two type of solutions. One is a compile time, the other is a runtime. Runtime usually require the hardware support. Compile time solution does not require hardware support. Okay. So first of all is okay, we can ask the people, okay, not use the the low-level programming language such as C or C++, so then we can prevent the buffer overflow attack. Okay, but it definitely causes some issues. Okay, because of some resource constrained devices, they can only support the C or C++. And we can ask them to use the self-coding techniques. So which means we have the senior programmer, they can inspect the code, okay, to see if they are using if their program are vulnerable to the buffer overflow attack. So idea is, okay, if you copy the memory from one buffer to another buffer, you always check the capacity of the output. So basically, the buffer overflow, this issue will not happen. Yeah. For example, like, okay, here is the example, just an unsafe buffer. Okay, byte input. So basic idea is, okay, they try to read, this function will read the data from file and write into a buffer. So he will call this function to get the file size first. Then they will try to write the file, all the data in the file to the memory. But he didn't check the output data, output buffer capacity is larger than the file length or not. So they will cause some issues. Okay. So another approach is, okay, we can replace the libraries, unsafe library used by programmers with a safe library, okay, by using the some rename technique. If we are using if you have some experience in the C programming language, then we are able to use a define. For example, we can define a string copy to the string n copy or string l copy. We can use the define techniques, which means we don't need to modify your program. We just need to modify your headers. Then we can force the users, we can force the programmers to use a safe library. Yeah. For example, the C library already divided in the C library, they already added the some string copy function like s string l copy. Yeah, for string copy, we have the 3 string copy function. One is a str copy, string copy. The other is a string n copy, and the final is a string copy. String copy basically they will copy the string. They will copy input string to the output string, no matter their length. Okay. String n copy means you allow to copy the first n characters from the input string to the output string. Okay. And the string L copy means it is similar to the string N copy, but it will check output string capacity first. If the output string capacity is shorter than the input, they will terminate. They will not overwrite this. They will not overwrite the other memory. So the string L copy is considered the safe function. So we can use a define this technique to redefine all the string n copy to the string L copy. By this approach, the programmers don't need to modify their program at all, and we can force them to use the safe library. Another technique is for the stack protection. So this one does not require the hardware support. We just need to modify our compiler. Okay. Idea is that we can add our compiler. We can modify our compiler to add the additional function and the code. When a function is invoked or when we ask it a function, we can add additional function, and this function will write a copy of return address to a separate region of memory. Once this function is returned, and we will go to check if the return address is different from the copy we saved in a separate region. And if these are different, we will terminate and abort this program. So basically, it's how we did in the stack protection during the compiler time. Yeah. We can also use a random canary. Okay, for example, okay, a few seconds. We can add one more parameter before the old base pointer. If then we can preset this value. Okay, for example, like the 111, 222, and the 3. If we find the random canopy is changed, which means a buffer overflow attack happens. Okay, which means we can put some gap patch before the old base pointer and the return address. Okay, if this random canopy is modified, then we are suffer from a buffer overflow attack, and then we abort this program. Yeah, so there's all for the compile time defenses. And next time I will introduce the real time defenses. Yeah, if any question, please come to me. Yeah, thank you.